Finally, we're going to talk about sound pressure level, or dB/SPL. And the reference we use for sound pressure level is 20 micropascals, or 2 times 10 to the first micropascals. And this is the pressure that's created in air by a sound wave with an intensity of 10 to the negative 12 watt per meter squared under standard conditions. So remember, dBIL and dBSL are related. There's not a linear relationship, but there is a relationship. So whenever the reference 20 micropascal is used, we're talking about dB/SPL, dB/SPL, dB sound pressure level. So when the air in the medium is energized by a vibrating source of sound, the individual air particles are displaced over a very small distance. We can now specify the magnitude of that small displacement more precisely. If a sound wave is a 1,000 Hz sinusoid with a sound pressure of 20 micropascals, the displacement of the air particle is approximately 7.6 times 10 to the negative 8 meters, so super small displacements. So their air particles are displaced a nearly infinitesimally small distance, and there's a certain wavelength that's associated with that change that happens to be much longer. So the relationship between absolute pressure in micropascals, dB/SPL, remember 20 micropascals is now our reference. 20 micropascals is now our reference. And here you go. Let's do some more formulas just like we did before. The relative value is dB/SPL on the left. The absolute value, 10 to the is in that right column, and we have our reference for dB/SPL, 10 to the first micropascals. So if we took the first value, 2 times 10 to the 6th over 2 times 10 to the first, what do we get? We get 5. 5 times 2 is 10 times 10. Remember, we're talking about decibels, and 100 is our answer, dB/SPL. For the next one, 2 times 10 over the 5th over the reference 2 times 10 to the first. 5 minus 1 equals 4. 4 times 2 is 8. 8 times 10 is 80 dB/SPL, and so on. So the reference is super important. As you move up the scale, the absolute value increases multiplicatively by powers of 10. For each tenfold increase in sound pressure, the dB/SPL increases additively by 20 decibels. The reverse as you move down the scale. And then there are some sampler problems. So the same 2 steps that you did to calculate dBIL, you select the proper equation. Remember, now we're doing 20 log 10 absolute over our reference, and our reference is 20 micropascals. Form a ratio and solve the problem. You can try to work through these sample problems. So to conclude, the relationship between dBIL and dB/SPL. If the intensity of a particular sound were increased by a factor of 10 to 1, the pressure of the sound wave would increase by only the square root of 10 to 1. And the decibel equivalent would still be 10 times 20 log 3.123 equals 10 decibels. Remember that the pressure is proportional to the square root of the intensity. Conversely, the intensity is proportional to the square root of the pressure. 60 dBIL does not equal 120 dB/SPL because the multiplier of 10 in decibels for intensity was changed to 20 for pressure. As long as the equivalent references are used in the 2 equations, dBIL equals dB/SPL. 20 micropascals is the pressure equivalent for our intensity reference of 10 to the negative 12 watt per meter squared. Thus, we can see that as intensity is increased or decreased by the power of 10, the pressure changes by the square root of 10. So decibels for sound intensity and sound pressure. There are 2-step solutions for these decibel problems. First, you have to choose the proper equation, then you form a ratio and you solve the problem. If it's an intensity problem, you use the 10 log equation. If it's a pressure problem, you use the 20 log